So I will present a series of work which have been done using mobile phone data and smart card data, and to analyze the potential of this data and limits, especially in terms of dynamic analysis. First, we work with, I will present first with the results with mobile phone data, and then with the smart card data. Traditional survey offer rich semantic, but with very low periodical realization every 5-10 years. We have also some other kind of survey which are available, but again with not very frequent information. So short-term dynamic analysis or intrapersonal variability analysis is very limited with this kind of data. So we have a potential with continuous passive data to analyze dynamic of behavior. Sorry, I cannot, yes. Mobile phone probe data exploration. We have used passive database with spatio-temporal information as that had been already presented. I would like just to insist in the fact that probe data are much richer than CDR data because they are less dependent to individual communication behavior, because we can have an over information, location area update when individual is moving from one location area to another, and periodical every 3 years in case of France information, even if the individual is not using his mobile phone. And lastly, attach and detach event. So we still have information even when individual is not using his mobile phone during his day. But we need to do some processing with this data. We have done, in the case of data, we have had access, and we have had access to raw data. It was not with commercial part of Orange mobile phone company, but it was with the Orange Lab, which is the research part of Orange. I have to notice that there is not a lot of communication between Orange Research and Orange Marketing. So with Orange Lab, we have access to raw data. So we could do different kind of filtering of data. First, we introduce the maximum interevent time, because in principle, we should have information every 3 hours. So we suppress the information when this threshold was not respected. We take also the entropy to avoid machine-to-machine devices. We also select only devices with at least 4 information, because with less than 4 information, it's not possible to analyze the stationarity and therefore identify trips. And lastly, we try to analyze household home location, but with strong difficulties is that we have only information for 1 day, because every day the identification of the device is changing. So our hypothesis is very limited for the household home location, which is only the information we have during the night. So the database we keep for the analysis was about 50% of the initial mobile phone devices. We suppress about half of these devices for the different analysis which has presented. Then we always try to compare the results we have with what we generally call the ground truth. Even I agree that it is not the truth, It's only the data we have in the past through household travel survey, but we have done this comparison. And here we have done this comparison with two thresholds to define trips, the threshold of 30 minutes and 40 minutes for the definition of activities. And the results are better for 30 minutes. Here we have the result on the left for the 30 minutes thresholds, and without the results for the lion conurbation. The analysis was for the whole Rhône-Alpes region, about 6 million inhabitants. And we suppress here's the data for the lion conurbation because the results was less good. So we have good matching with a slope which is not so far from 1 and a very small constant. Further, we analyze the temporal profile, and the first profile we have on the left was not very good to identify the peak period. So we developed two steps to correct this data. And after these two steps with external data, we get better slope and a better temporal profile. And then we apply this temporal profile to different zones. Here you can see the result for different zones only for trips which are starting for the different kind of area. And we can see that we have different profile depending on the type of zone we can have, which is an interesting result, which is not always very easy to get with traditional data, because we do not have always enough information to do this kind of analysis, especially when we want to analyze audiometrics. The second kind of analysis is with smart card data. In this case, we analyze the data on the lion conurbation, which is about 1.3 million inhabitants, where we have smart card data, magnetic paper ticket for those who do not have the smart cards, about 20%, but without ID in this case. And other kind of data, which is listed here with the automatic vehicle location, passenger counting, our origin destination survey, which are done every 5 years for whole bus routes, our tram and subway bus routes, and household travel survey, about every 10 years with about 1% stratified sampling. Again, data correction is needed and some imputation is also needed, and especially we need to impute the destination, and after we need also to do some kind of data expansion, because the data we have with smart cards with the lighting location imputation represent about 50% of total transit trips. So we have done this expansion not with uniform scaling factor, but using passenger counting information to have spatiotemporal scaling factors. When we analyze the results, we can see that smart card data give very similar results than the origin destination survey, but much more different from what we get from household travel survey. And especially we have a difference with one trip only, which are more numerous with smart card data than with household travel survey, which has been also observed in other countries. When we compare, we can see again that on the right that the match is much better at OD level between smart card data and OD survey than with, on the left, household travel survey. We the fact that we have a lot of information allows us to follow individuals during a long period. Here we have the same ID for smart card data for 6 months, so we are able to analyze the use of each card during 6 months. And here we have a representation of dendrogram who indicates that we can identify mainly 3 groups: a consistent transit user, a low frequency user, and intermittent user on the bottom. The consistent user represents 45% of user and 69% of trips. And now we will analyze only consistent transit user. And we do some cluster analysis to identify different kind of patterns. I think I will not have enough time to describe each cluster, but you can see here, for example, in C3, that we can identify clearly the holiday period, which are white, and the weekend, which is much less the case for C1, for example. So we can identify different kind of pattern of use of public transport. So in conclusion, big data are not error-free, so we need to define filtering process, for example, to suppress machine-to-machine devices or devices with too few data. Smart card data also need some correction factor, and data imputation is required to impute missing information. Big database also need expansion factor, because even if it is a very big data base, it's not exhaustive and do not represent the whole population, because some individuals might have no device, or on contrary have several devices. So we need to define expansion factor, and we can see that expansion factor are better when we define spatiotemporal scaling factors using external sources to improve these scaling factors. Big data require also to confront the data with other sources. What we generally say is ground truth, even if it is not the truth, we know very well. But we need to confront with other kind of source just to assess or try to assess what is the probable quality of the data. And we need to do it regularly, because big data sources evolve continuously. And big data are also often context dependent. So we need to do this regular comparison with other kind of data source, and it's generally recommended to use external information, and obviously external information which is not used in the data processing. But even if there is some limits, of course there is a high potential to do some kind of analysis, and especially have been presented very rapidly, but we can do aggregate or disaggregate regularity, variability analysis, especially when we can keep the same ID for individuals or devices. We can do some intrapersonal variability analysis, which is not possible with more classical data we have. And we can do also very detailed spatiotemporal analysis, including OD matrix analysis at very fine grain level, which is very often not possible with other kind of data, because we do not have enough information. And that's it for now.